All right, thanks for having me here today. Great session there from Peter, introducing us to the type of content we're going to see today. And what I would like to talk about today is how to figure out how to trust the output from AI. Specifically, I want to ask a particular question, which is, what is our current problem that people are having with trusting AI? And why don't we trust the output from it? So I think the issue breaks down into two separate problems. One is the quality of the results, and the other is the lack of transparency into how that result was actually achieved. So if we look at the first one, I think there's a lot of variation. I think we all know that there's a lot of variation in AI outputs and results. And some are just amazing and others are really bad. But in general, I think the trend is heading towards it being more consistent and higher quality. So I'm not really worried about the quality issue. I think the much bigger issue is the second one, which is we don't know how these AIs achieve their answers. We don't know how they got the results. We can't see into it. It's a bit of a black box. And that makes people upset, or at least that's what we tell ourselves. So I think we're forgetting that if you give a bunch of different security people a different test, or you tell them to test the same thing, that they tested 6 months ago, they're going to come up with extremely different results, and they're not going to be able to explain why. And I think that's a thing we need to think about. Like, we've all worked at companies where we're trying to get humans to do a thing, like fill out some paperwork or fill in a document, and it needs to be done in a very specific way. But people might not read the document. They might forget to read the document. They might misread the document. They might misinterpret something, or maybe they just had a bad day and their brain just isn't working the same. Basically, I think we're a lot more variable and we're a lot more of a black box than people think. So I think this bias against AI is actually a bias towards humans just because we're so used to dealing with ourselves. And I think we're pretty bad at a lot of things. It reminds me of people not trusting automation for cars, like autonomous vehicles. This is a thing that I think is the exact same bias. It's like they might see the data that says autonomous cars are more safe, but they still trust them less because we know human drivers. We are a human driver, and it just doesn't seem as bad. But one thing I find really interesting is there's surveys of bicyclists talking about how much they'd rather be sitting right next to a Waymo than, like in the blind spot, for example, than sitting next to a human driver. Because human drivers frequently, according to these surveys and a lot of people's experience, they'll just turn because they didn't happen to look, they didn't happen to see them. Whereas if it's a LiDAR and it's going around all the time, they're not going to do that. Also, a human driver might be looking at TikTok while driving, where a Waymo is not going to do that. But the point here is not to fix the human bias, it's actually to look at how we can get transparency into the AI bias. So I think the best way to think about AI in the context of business is to imagine business operations as being like a sequence of different intelligence tasks. So let's say you work at like an insurance company and you need to validate whether or not you're going to pay out this policy. So there's a series of like intelligence-based tasks that you have to go through to do this. So you look at the pictures that were taken of like the impact or whatever. You review the policy, you watch interviews if there's like video to watch. And then you make your decision as a human. Or here's another flow for a business. But the point is you could break down any business in this way. And I call these flows pipelines. This is how I think we're going to start looking at the world and all business processes as a series of these steps linked together. So I think the main way AI is going to affect business and human jobs is by replacing one by one each of these discrete steps in the process, and eventually the entire intelligence pipeline, which are basically our everyday business workflows. So taking in the image, gathering the evidence, reading all the evidence, listening to the interview, all those different pieces, which are being done right now by me as the human doing this job, each one of those will slowly get chipped away. And eventually that whole pipeline is going to become AI. And some things will be hold out for quite a while and other things will go pretty quick. Because each of those is an intelligence task and all of them together make up this flow. So let's look at another example. And this example is in the security space. This is a piece of code, which is a Flask application and does a whole bunch of stuff with customer data. So it's processing a bunch of stuff. It's taking input from forms. It's putting that into a database. It's doing a whole bunch of different stuff. And we need to know if this is safe for production or not. So this is a common thing that regular security teams are doing. So it's an intelligence task being done by humans because traditionally humans are the only ones with intelligence of this level. So the output here is a pass or a fail. This human is going to look and say, no, this cannot go to production, or it can. And this is really the key. That last step is really the thing that we care about. We need to be able to get an answer, a pass or fail. And we need to be able to respond to an auditor, right? We've all been in that situation where it's like the auditor wants to understand the process and the thinking behind it, and they want some sort of transparency. Why did you trust this output? So what I believe the answer is to have multiple different analyses and multiple different engines that hit a particular AI result. They do their analysis, then they show their results. So rather than business pipelines or intelligence task pipelines, these are validation pipelines. So what I actually did here to demonstrate this is I took the code and I hit it with 3 different systems. So I hit it with Snyk, I hit it with an AI-based code scanner, and I hit it with a corporate, like, secure code policy. And that was looking at different rules, which we'll see in a second. So this is how I ran the Snyk code test on the code. And I'm using AI here. So I'm taking the results, sending it to the AI, and then I'm also producing a JSON output, which is the result of this thing, and saving that off. And this is what the output looks like. So this is the JSON that came from that thing. So this is the different stuff that Snyk found. Then I ran an AI version of this using, I'm not sure which model was for this one, but they pretty much all came back similar. And got back different results, right? Got back different results, not quite as good in this case as the Snyk ones. And it produced also a JSON output. And then here's the policy that we ran against it. And this is very rudimentary, as you can see. But what this essentially shows is we're basically saying to the AI, look, we don't want SQL injections. We don't want improper error handling. We don't want any of these things in our code. This is against our policy, so flag that if it happens. So now we have three results using very different techniques, right? You've got a code scanner produced by a private company. You've got an open source or some kind of AI model that's kind of generically doing things. And then you have a completely different type of test which is policy-based as opposed to technical-based. And the separate evaluation is happening for all 3. So the cool part here is we're using this 4th piece, which is the top level, also AI component, but it is looking at the results of all 3 combined. So this is the evaluation that we used, and this one was specifically Llama 3.1 that we use, which is an open source AI tool and open source AI model from Meta. So I'm telling it to read all the output files of all the previous steps. So we did 3 different tests. We did Snyk, we did the AI, we did the policy. So all of those have now been output, and now we're giving it some in-depth instructions concatenating all of those results. And we're telling it, not only do I want you to make your own judgment, but I want you to make your own judgment and describe the process. Describe your reasoning for why you came up with that decision. So look at this result. It produced a flow chart because we asked it to. So if we go back here, we asked it to produce a flow chart. We asked it to combine the results. We asked it to pay attention to the different steps. So like we're giving instructions on how to do this. This is quite easy to do. And the result here is it output this flow chart in Mermaid format, because that's the format that we asked it to produce this chart. Then it gave us specific reasons for why it came up with its conclusion, including multiple scanners used, consistency of results, etc. And then the result, most importantly, it gave the result of fail, not secure for production. And I find it really interesting what it actually said to us here. I mean, multiple independent scans performed. You have to think of this in terms of, you're handing this to an auditor who is questioning, or whoever. It could be a customer, it could be a regulatory body, it could be anyone who wants to know why you did this, why you pivoted to making this decision for this business, like what went into it. We've already talked about how humans are, more of a black box. So that would just be a human talking to a human, or maybe describing in a document or something. But you can't necessarily ensure that they followed that process when they came up with their decision. The idea of this is to be even more transparent than humans, right? So look at the top level of the summary here. Multiple independent scans were performed. Sneak, AI-powered, and company policy check. Each scan used different approaches. Comprehensive coverage, so it did all three of those. Consistent results across all scans. That's a great reason to trust this result. All three results actually said fail. Okay, it failed the policy, and it failed both code scanners. And it mentioned the vulnerabilities that were found, and it came up with its conclusion. So you remember the chart. This is what the chart produced. It produced a graphic for us. It produced a visual layout of the steps that were performed. So it clearly shows that we have a validation pipeline. We have 3 different approaches used, the results from each. The fact that all 3 failed goes into the final decision, unanimous fail, therefore do not allow this into production. So now imagine military decisions, health decisions, personal decisions, all the way down to triviality of like picking the best restaurant, or like what kind of ice cream you want to eat, whatever. There are some decisions that are really important and some decisions that are trivial and it doesn't really matter. So what I believe is going to happen is the more sensitive a particular decision is, if it involves the military, if it involves essentially humans and human benefits and welfare, such as healthcare, things like that, it's going to require more validation of more different types and more stringent analysis, and perhaps even like a human in the loop to actually do the final sign off. For example, you might need an MD to actually sign off to say this is good or bad or whatever, after it went through this whole set of things. So if I'm right about this, the way we're going to end up trusting AI results is by using AI to help validate and explain those results. So we'll have AI run multiple disparate types of testing on AI outputs. They will describe their methodology and the results from each of those discrete steps. And it'll result in an output that describes the entire process and why you should accept the result. And that is how we're going to come to trust the output from AI. Thanks for your time.